In this video I'm going to do some examples of equations with rational expressions. This time I actually remembered to write out all three of the examples that I'm going to do. Sometimes I forget to write them out at the beginning of the video, but at this time I'm going to go ahead and get started. So for the first example, we have 1/2 plus 5 over 3x equals 2/3. So 1/2 plus 5 over 3x equals 2/3. So the first thing I want to do is find out what the lowest common denominator is. So the LCD in this case, I'm going to write it over here. But I'm also going to write it out underneath, just because it'd be nice to have it in print, I guess, because it's something more permanent. So it's going to have 1/3. I don't know why I started with 3. Let's start with going from left and moving to the right. It's going to have a 2 in it, because there is a 2 here. It's going to have a 3 in it, because there's a 3 here. There's going to have an x in it. Okay, so how many 2's is it going to have? 2 occurs at most one time, so that means it's going to occur once here. 3 occurs at most one time, because it occurs once here and once here, no times here. So it's going to have one of them here. X occurs one time, so it's going to have x here. So this is going to equal 6x. So I'm going to put that down here. The lowest common denominator is 6x. So now the next thing I want to do, now that I have the lowest common denominator, is I want to multiply both sides of the equation by the lowest common denominator. So that will give me 6x times 1/2 plus 5 over 3x. Okay, so 6x times 1/2 plus 5 over 3x equals, I forgot the 6x. So all I did was I multiplied both sides of the equation by 6x. So now that means that I can go ahead and distribute this 6x. So that's going to give me 6x over 2 plus 6x times 5 over 3x. So I just distributed this 6x to here to get 6x. This was technically, if you want to do it the long way, it'd be 6. Well, that's not like a 6. 6x times 1/2. Then you multiply across, you'd get 6x times 1 is 6x. 1 times 2 is 2, so that's where I got the 6x over 2. And then I'm going to distribute the 6x to the 5 over 3x to get 6x times 5 over 3x. Then I want to deal with the right side too. So that's going to be 6x times 2 over 3. Okay, so what can cancel? Well, this 6 can cancel. I just divide the top and bottom by 2, so I'll have 3, 1. And then this 6 can cancel here, so we'll have 2, 1. And this 6 will cancel here, so we'll have 2, 1. So all I did, as a refresher, all I did for this was I reduced the fractions by canceling out unnecessary terms. So like I have 6x over 2. Since I have an even term here, I can say this is equal to 2 times 3 times x over 2, and the 2's cancel. You can think of it as a shortcut way, just by thinking, okay, well I have an even term and an even term here. Well, I have something that can be divided by 2 and something that can be divided by 2. So this will be, I just divide both of those by 2 and I have 3x over 1, which is just 3x. So at any rate, let's go ahead and go on to the next line, and I'll write down all of these changes. So that gives us 3x, get that out of the way, so 3x, let's put a little bit more room there. Oh, that's a lot more room. Okay, so 3x plus, and then 2 times 5 will give us plus, whoops, I didn't mean to do that, plus 10. Oh, and the x's cancel. I forgot to cancel these x's. Excuse me. Plus 10. 3x plus 10, because 2 times 5, everything else is canceled, equals, and then we have this 2 times 2 times x will give us 4x. Okay, so we have 3x plus 10 equals 4x. So hopefully that makes sense how I did that. I'll go through it one more time though, just in case it was confusing. So I distributed the 6x here and then multiplied across here. I canceled all unnecessary terms. Remember that from previous videos about cancellation involving factors. And notice this is a dot here, not a plus or minus. That would not, if that had been a plus or a minus, that would not have worked. And then here we had the 3 left over and the x left over, a 2 and a 5 left over, which make 10, and then a 2 and a 2 left over, and an x, that makes 4x. So let me go ahead and clear all that off. And now I can go ahead and subtract 3x from both sides. We'll get 10 equals x, which is going to be our final answer. But remember, always remember, that you want to check your answer. So I'm going to go ahead and, I think I can box this using the aha. So I'm going to box this answer, but I'm also going to check it. So let's go ahead and check to see if that works. So I'm going to put this 10 in for here and see if it works out. And especially what I'm going to look out for in particular is, does this ever result in dividing by 0? So we'll go ahead and evaluate this from the left and evaluate it from the right and see if they match. So 1/2 plus 5/3 times 10. Now I need to see if this equals the right side, which is 2/3. So 5/3 times 10, that's going to equal 5/30, because 3 times 10 is 30. I just multiplied these two together. And now I want to combine these two fractions. Actually, first thing I want to do is simplify this one. Divide both sides, top and bottom, by 5. So this is going to be 1/6. But then I still want to go ahead and combine these two, add these two together. So that'll make this 3/6 plus 1/6, and then that's going to be 4/6. I just added across here. 3 plus 1 is going to be 4, and then this 4/6 reduces down to 2/3, which is the right side of the equation. So we know we did it correctly. And more importantly, we know that we never end up dividing by 0, because that's what we want to watch out for. That's when we say, okay, we have no, that would mean that we don't have a valid solution. Alright, so now let's go on to the second example, which was x plus 1 over x minus 1 minus x over x plus 3 equals x plus 6 over x plus 3. This one, as you can probably kind of see already, is kind of long. It's going to take a while to figure it out. First of all, what's the LCD? So I'm going to do that down here. LCD equals, and it's going to include all the individual factors, of course. Well, what factors do we have? Well, we have x minus 1, and we have x plus 3. And how many times does x minus 1 occur at the most? 1 time, so our exponent is going to be 1, so we can just ignore it. And x plus 3 occurs at most 1 time. So, let's go ahead and multiply across by the LCD and see what happens. So, let's go ahead and first of all write that out. So, x minus 1 times x plus 3. And let's multiply across and see what happens. So, if we multiply, and I'm going to go ahead and do this a little bit in my head, and you can hopefully you can see this. If not, feel free to write it out on paper. But when you multiply this right here by this, what you'll see is that this will cancel with this, and you'll have just x plus 1 times x plus 3. So x plus 1 times x plus 3. Okay, so then we still have the subtract here, and then when you multiply this by the LCD, what you'll see is that this will cancel with this, and you'll have left over x times x plus 1. And then over here, this will cancel with this, and we'll have x minus 1 times x plus 6. Now we do a lot of multiplication, and we go ahead and we FOIL this out like that, and we will find that that turns into x squared plus 4x plus 3 for this part right here. Then over here we'll have minus x squared. I did something wrong. I'm so glad I caught that. That should be x minus 1, because when you cancel with the x plus 3, you're going to have minus 1. Okay, so then we have x minus x squared minus x. Whoops, I put that in the wrong place. Okay, so all I did here was I distributed this x into the x and negative 1, so we have x squared minus x. And then we FOIL this out here. We will get x squared plus 5x minus 6. So let's go ahead and on the next line, I just want to go ahead and distribute this negative, so we'll have x squared plus 4x plus 3 minus x squared plus x. I just distribute this negative to this negative here, and this negative. Sorry, distribute this negative to this positive and to this negative. So then, of course, the right side remains the same: x squared plus 5x minus 6. And now we have this x squared cancels with this negative x squared, and this 4x and this 4x become 5x. So let's go ahead and combine these like terms. So we'll have 5x, and then we have there's no other. Okay, so I'm done combining these terms. I'm crossing it out, not because they're canceled, but because I'm done with them. And then there's the only thing left here is this plus 3. Now I'm going to go ahead and pull everything here to the left. So that means I'm going to subtract this from both sides of the equation. So we'll have minus x squared, and then minus 5x minus 6 equals 0. Okay, so now oops, I'm very glad I caught this mistake. Plus 6. See, if I'm subtracting this from both sides, I'll be subtracting x squared. So I'll be subtracting it from this side too, subtracting 5x. But then to cancel this negative 6, I'll be adding 6. Okay, so once again, I'm glad I caught that. So now we go ahead and we can see that we can cancel this 5x with this negative 5x. And that'll give us negative x squared. I'm just using this term first, and then this plus 3 plus 6 will give us minus 9 equals, oops, plus 9. Gosh, I have a lot of plus and minus mistakes today. Plus 3 and plus 6 gives you plus 9. Now I'm going to go ahead and rewrite this as you can either multiply both sides of the equation by negative 1, because since we have 0 here, we can multiply this by both sides of this by negative 1. You'll get x squared minus 9 equals 0. In fact, that's what I'm going to do. That doesn't hurt anything. So x squared minus 9 equals 0. You could also rewrite this as 9 minus x squared. Either way will work. Let me, to the side over here, show you what I did. So if we have negative x squared plus 9 equals 0, we can multiply both sides of the equation by negative 1. And just want to make sure I have enough room here. Distribute this negative 1 to the negative x squared. This negative x squared will just become x squared. This positive 9 will become negative 9. And then when you distribute the negative 1 to the 0, negative 1 times 0 is just going to be 0. So you have x squared minus 9 equals 0. So now what we have is a difference of 2 squares, because you have x squared minus 9. 9 is 3 squared. So we can rewrite this as x plus 3 times x minus 3 equals 0. Now we have two different things that would multiply together equal 0. So x equals negative 3, or x equals 3. Because x equals negative 3 will make this 0. X equals positive 3 will make this equal 0. But we're not quite done, because we need to check our answers with this up here. In particular, we only care if it ever divides by 0. Now, it's good to go ahead and check your answers throughout the entire thing. Check it to make sure that both sides are equal. I'm not going to do that now just for the sake of time, because this is already a really long example. But it wouldn't be bad practice to go ahead and plug negative 3 in for x, see if the left equals the right, then plug 3 in for x, see if the left equals the right. For now, the main thing I'm going to do is I'm going to make sure this never divides by 0. So we have two different solutions here, so I need to check them both individually. Does x equals negative 3 ever divide by 0? Well, yeah, it does right here. Because if you put negative 3 in for x here, you'll have negative 3 divided by 0. So you can't divide by 0, because if you have, here's just a quick example. I've heard some people say, well, if you divide by 0, the answer is 0, right? But no, that's not it. Think of it this way. So if you divide, if you divide 4 by 2, in some sense, what this is saying is, how many times do you have to add 2 before you get 4? So 2, well, that's not right. How many times do you have to add 2 to get 4? So that'd be 2 plus 2 equals 4, which means 2 times 2 equals 4. So you're saying, how many times do you have to add 2 to get 4? 2 times. That's why 4 over 2 equals 2. Well, what about 4 over 0? How many times can you add 0 to get 4? Okay, let's add 0 plus 0. Okay, well, that's still 0. Plus 0, still 0. You can go on and on and on. No matter how many zeros you add, you're not going to get above 0. That's why you can't divide by 0. So what this is basically saying is solve what this is saying is solve this equation, x times 0 equals 4. Well, there is no way to solve that because anything times 0 is 0. So, getting back to this example, what this means is that x equals -3 is not a valid solution to this problem. Because when you plug it back into this right here, you're going to get a division by 0. So that means we want to cross it out. So I crossed it out right there. And now we check 3. Does 3 work? Well, 3 minus 1 is going to be 2, so that's fine. 3 plus 3 will give us 6, so that's fine. 3 plus 3 is 6, so that's fine. So that means this is a solution that works. So this one, I'm going to go ahead and box that. So x equals -3 does not work, but x equals 3 works just fine. Let me put that in the same text, same font. So we checked it. We didn't go to the point to check to make sure that the left side equals the right, just because of purposes of time. But we did check to make sure it never divides by 0. Again, it never hurts to go ahead and check the left and the right side individually. Okay, so one more example. This should be just a little bit easier. I intentionally made that one kind of hard. 2x over x plus 3 equals 2x over x plus 3 equals x plus 4 over x minus 2. Okay, so we need to find the lowest common denominator. Oops, just a second. The lowest common denominator, I'm going to do this up here as well, is going to have an x plus 3. It's going to have exactly 1 because that's the most it occurs. And it's going to have x minus 2. So the LCD, and it's going to have an x minus 2 just once because it only occurs once. So the LCD is equal to x plus 3 times x minus 2. Oops. X plus 3 times x minus 2. Okay, so now we go ahead and multiply both sides of the equation by that. So we'll multiply both sides of the equation by x plus 3 times x minus 2. And we will get now hopefully you can see this by now. When you multiply this left side by this x plus 3 will cancel. You will get 2x times x minus 2. And for this right side, you will get this x minus 2 will cancel with this, and you will just get x plus 4 times x plus 3. Okay, so we double check that to make sure, because sometimes when I talk and do math at the same time I get mixed up. So multiply this side by x, the x plus 3 will cancel, you'll have 2x times x minus 2. Over here, the 4x minus 2 will cancel, you'll have x plus 4 times x plus 3. Okay, that is correct. So we distribute this 2x to each individual part here. We will get 2x squared minus 4x, because the 2x goes to the x, the 2x goes to the negative 2, equals, and this is going to be x squared plus 7x x plus 12. And then we can subtract everything from here over here. So we will have x squared, because 2x minus x squared will give us just x squared, and then minus 4x minus 7x will give us minus 11x, and then minus 12. There's no like term over here to combine, and all of that equals 0. So now let's see if we can factor that out. Turns out that we can. That is equal to x minus 12 times x plus 1 equals 0. So now we have that two things, when we multiply them together, equal 0, so one of them has to equal 0. So either x equals 12, x equals 12, or x equals negative 1. So now we see, do either of these answers ever divide by 0? So x plus 3, so let's look at 12 first. 12 plus 3 will give us 15, so that doesn't divide by 0. 12 minus 2 will give us 10, so that doesn't divide by 0. So x equals 12 is a valid answer. Let's try x equals negative 1. Negative 1 plus 3 will give us 2, so that's good. Negative 1 minus 2 will give us negative 3, so that's good. So this is a valid answer. One thing to bear in mind is that it is very possible, none of the examples I did here do this, but it's very possible that none of your answers will be valid. And when that's the case, you just write down no solution. Alright, I will see you in 7.6.